We're going to kick off Kris's presentation. Take it away, Kris.
Okay, so welcome everybody. So I'm going to show you a demo of Spring Tool Suite and all the stuff we have built into it now for working with Spring Boot applications. So who knows what STS is? Spring Tool Suite. Okay, so I may not need to say too much about it, but STS is an extension of Eclipse. So every time there's a new release of Eclipse, we put out our bundling of Eclipse plus all our tools. From that URL there, you can always download the latest version. And actually, I'm not going to talk too much slide. I'm just going to jump right into a demo. Okay, so let's switch demo. So this here is what you see on the screen here. This is STS. And the thing on the left here, this view in the bottom, that is the Spring Boot dashboard. So the Spring Boot dashboard is there to bring together in one place how you work with boot applications in STS. This demo will have two parts. In the first part, I'm just going to talk about how you work with local applications. And in the second part, we'll also see how that integrates with Cloud Foundry, so you can deploy your applications directly from STS to the cloud. Okay, let's get started. So when I open this view here, what you see in here is a list of all the Spring Boot applications in your workspace. And the idea is that since you're going to be working, you'll probably want to build lots of little boot applications. You're doing microservices. So we wanted to make this dashboard to make that easy, to make working with multiple applications at the same time much easier than it is up to now. So first of all, you get this list all nice in one place, and you get a little filter box at the top, so you can sort of type something and it filters the list down because maybe you don't want to work with all those applications at the same time. Focus your view. So for my case here, I've got a few things in my workspace, but I don't care about all of them because I just want to work with the ones that are my demo right now. So this is a small little chat application. It consists of 5 little boot microservices. They talk to each other through Spring Cloud Streams. And they all show up when I type chatter here. Some of them have chatter in their name. And there is one that doesn't have chatter in their name, but you can tag them with tags as well. So that's kind of flexible mechanism. You can either use the name or you can tag things explicitly. And of course, since this application consists, each one of these is really a tiny little boot app, but in order to run my application, I have to run all of these things. So I don't have to launch them individually. I just select them, click start, and all my applications are now starting up. And you can see here in the console, I can see the output from my applications. I can, of course, since I have 5 of them, there are also 5 consoles. Could be a bit confusing. You can switch between them quickly. Just select here and click this terminal icon there, and it will switch to the corresponding one. Another neat feature is that it gives you an overview of what all the ports your applications are running on. So as you can see, these ones here have sort of randomly picked port, and these 2 are running on very specifically assigned ports. So my user interface is this one, is the Chatter web UI. So let's open that. See, as it detects the port, if I double click it, it knows what URL to open. So I don't have to go open a browser, type something in there, try to figure out what port it runs on. So that's all very easy. And I can quickly demo this thing to you. Another thing I want to show you, this is actually kind of a newish feature since STS 3.8.0, is we now make it very easy for you to run multiple instances of the same app. That's something you might want to do that if one of your services can be replicated and load balanced and you wanted to test that locally. Maybe you want to run more than one instance of the same thing. So let me show you here. I'll launch another instance of this web UI. So click on it, and then there's an option in this context menu to duplicate its launch configuration. And you notice that this little thing appears here. I can expand it now. This is the one I had before, my launch configuration I had before. It's already running. There is a duplicate. It's not running yet. I click on this pencil icon. It will open the launch configuration editor. And now I can customize it. So since this UI is running on a specific port, if I were to just launch it now, it will just fail because there is a port collision. So we have to customize that. In this place here, you can define additional properties to override in Spring Boot properties. So I'll type port. Notice we have some nice content assist in there, so you don't have to remember all the names of these properties. I select server port, and I give it a different port, 8081. Save that, and launch it. Okay, it starts up. And now notice that you have a little summary here. If I collapse this node, you can still see I'm running 2 instances, and it's running on 2 different ports. Yeah? I can double click this one too. And now I have 2 browsers open, and each browser on a different URL. So these are now connected to 2 totally different processes, right? I just wanted to do that so I can show you that they are actually talking to each other. See? If I type in one window, the text appears in another. Even though these are 2 completely separate processes, how does this work? Well, all my applications here are connected through Spring Cloud Streams, which uses, in this case, in the back end, a RabbitMQ instance to send messages back and forth. Okay? I'll show you later a little bit how to use Spring Cloud Streams as part of my coding. So that's more or less what I want to show about this view here. So now I'm going to do a little bit of coding. We're going to add another microservice to this application so that we also see how to create an application from scratch and what kind of tools we have for that. So first, let's start. I'm going to create a new Spring Boot application. So we go to here, new Spring Starter project. So this is a wizard which is backed by the start.spring.io web service, which you probably have heard about. It's pretty common. You've seen Rossen used it earlier, I think, and so this is a pretty common thing. But this is basically the same thing with the old-fashioned SWT widgets in front instead of a web user interface. Okay, so most of these boxes I don't have to type anything right now because the wizard remembers what you put in there last time. So all is already filled in for me. On the next page, I get to select the starters. Actually, these buttons, if you install STS now, they won't be there because those are brand new. You can now save your selection as a default, and it will automatically tick some boxes for you. So that if you always use these 3, for example, then you just make them the default. You don't have to tick them anymore. This list remembers what you've used a lot. They will always show up at the top, but you can also start digging in here to find others, and you can type in this box to search, right? All the things I wanted to use are pre-selected, so I just basically have to click finish. What do I have got here? Actuator and web, which is kind of standard for almost any application, and then the stream rabbit. That's the way my services really talk to each other using RabbitMQ with Spring Cloud Streams. So I finish this. I click finish. My application is created. See, it appeared here. It's also up there. Quick little demo of this feature here. You can click open in Package Explorer, which will highlight it over there. Yeah. Okay. So now we can start writing some code. So I'll be using Spring Cloud Streams, and we're going to have to enable that. So I'll do enable, yeah. Sometimes the content assist the first time is a little bit slow because Eclipse is kind of parsing the universe, but it's ready now. So enable binding, and then we have to put a class in there. This class represents your communication pattern with the rest of the world. So, or actually it's not a class, it's an interface. What I'm going to make is called it's kind of a little robot. It's going to send messages to my chat channel, just like ping, ping, ping every so often. So this kind of communication pattern is only sending messages. That's called a source. And Spring Cloud Streams give you, for that, a prepackaged interface. So you don't have to define it yourself. You can define your own patterns as well, but there are some common ones like source and sync and transformer that are predefined. So we just use those. Okay. Once we've enabled that, it will create a bean automatically. We can use that bean. We can use that bean here. I'll call it channel, and that's how we're going to talk to our other apps. I'm going to auto-wire it. This is a little quick fix to add this annotation. This doesn't save you much typing, but a little bit. Yeah. Good. That's my channel. I need to start my service, or the bot will have to start doing stuff at some point. So I'll add a method post construct, which will kick it off. And my little robot will send messages every, let's say, 3 seconds. So we need something to execute a little bit of code every 3 seconds. We'll use Spring's task scheduler for this. Task scheduler here, yeah. We get this one for free too. The only thing we have to do is ask nicely. Just like a lot of these things, put something enable there and it will work. Okay. So now and I shouldn't forget to add the auto wire to that as well. Okay, so we have a scheduler, we have a source, that's all we need. Now we can use the scheduler to execute something. Schedule at fixed rate. We have a task there. We can use a lambda expression because we're using Java 8. And put 3,000 milliseconds there. And then we use that channel to send our message to the other apps. Channel, output, send message. Send the message, we use message builder to create the message. With payload. So the payload is what we want to send. It's just a little string with a message. It says ping. And we'll add a little counter to it so that the messages are not totally boring. Plus, like this. We'll create a field for that. And message builder dot build. Sorry, I'm futzing a bit. Let's just adjust this a bit. Okay. So yeah, that should work actually. Actually, there will be a few problems that I'm going to have to solve, but that's a good opportunity to show you some of the tools we have to help you solve problems as well. So let's, if I run this first, let's run it first and see what happens. So I click run. Actually, I clicked the wrong button, sorry. I'm rerunning something else now. So we'll select this guy and run it. And you'll see that it starts but doesn't quite start. Something's going to go wrong here. See, it didn't start up. Something was wrong. What was wrong? We have a port collision again. So I could do the same thing as we did before, change that launch configuration, but let's do it a different way this time. So we can also configure our Spring Boot applications by editing this properties file here and specifying the properties in here. And we have a nice editor for this properties file. So you see the content assist here as well. And actually, I'm going to change this file to a YAML file because Spring Boot supports two formats for editing your properties. So you can either use the Java properties file format, or you can use somewhat more nice, friendly format for developers, which is more flexible, more complicated, but we have a good editor for that too. So I'm going to switch that to a YAML file. Okay. Okay. So rename it. I'll rename it. And so now it's going to be more nicely nested. Okay. We'll set the port to 0. 0 means to Spring Boot. So you can pick a specific port, but if you set it to 0, it means pick one yourself, basically. So Spring Boot will decide what to use. If I run it now, it should actually launch. So let's run it again. It should start up properly this time, yeah. And see it pick the port, 42,713. That's a nice number. Okay. I can look at my web UI here. I don't see any messages though. And actually, I think I made a mistake earlier. I actually killed my web UI by relaunching it. So let's just reopen that web UI because I made a mistake earlier. So let's put it back here. Okay. So we don't see any messages. So let's add some. So something's not quite done. I'm not done with implementing this. There's a few pieces missing. So first, I'm going to add some debug messages, logging messages, so we can see if something's actually happening. So let's go back to our class and add some logging to it. Spring Tool Suite 3.8.0 added a few templates, which is basically little code snippets that you can just paste into your code. And we asked all the Spring Boot developers for giving us as many of these as they could think of, and then we put them into STS. So this is one of them. It creates a logger with the typical pattern for instantiating a Self4j logger pattern. Okay, so that's with a few clicks and a few keystrokes, you can insert this snippet, and we can then also use it for, this is another little template for sending messages to the logger. So let's say a debug message saying that this thing is starting. And also when it's sending a message, let's put a debug message there. Sending message. Okay. Okay, there's a typo there, but I'm not going to bother with that. Do we see anything in here? Let's make sure we are. Do we see anything? I still don't see anything. So either it's not working, or maybe I actually have to enable the debug messages, because by default the logger level is not set as high that the debug messages will come out. So we'll have to do that. So let's go our YAML file and enable debugging messages. So we can do log level. There's a property, a Spring Boot property for configuring your logger. It's a map, and in the keys of the map you have to put a logger name. So if I type chatter here, you see what we also get some content assist, because the name of your loggers are usually packages or classes, so it suggests those. So let's take our demo application class, and you see also content assist suggests what the correct values are. So we can say, okay, set the log level to debug there. And okay, still nothing happening, but actually I have to relaunch my app, right? Now, every time I make a change, I'd have to relaunch my app. Yeah, that's kind of annoying, right? So let's add another tool to the mix. So there is a thing that one of the Spring Boot developers made, which is called Spring Boot Dev Tools, and that kind of auto restarts your app every time something changes. So let's add that to the mix. Also gives me a chance to show you a nice little feature of STS that's very little known, because we probably have to put it in another place. People forget that it's there. But if you click on your POM file here and you select from the Spring menu, you have Edit Starters. You open this. You get back to that same view that we used to pick all the starters. Now we can basically change our mind and add a few more or remove some. So I'll add the DevTools to the mix. Okay, there we go. And now this is the last time I'm going to have to restart this, because from this point on it'll just restart itself. Okay, so let's restart this guy here. And I was expecting some messages to come out. Oh, sorry, yes, you're right. I have to start this guy. I hope I added the POM to the right app though, yes. Okay. Okay, let's restart this guy. Okay, so now we expect to see our debug messages. Yes, there we go. So, see? So it's working there. Still no messages in the UI though. And also the browser is acting a little funny. Okay, let's just open it again. Okay, let's put this guy here again. Okay, so why are there no messages coming out? Is because we have used the Spring Cloud Streams. In the back end, there is, when you use that, it will set up some stuff on RabbitMQ, configure some exchanges and queues and things like that for you. You don't really have to understand too much how they're configured, but there is a kind of a resource there where you send your messages. And then they get sent to everybody else, right? So this kind of a channel there, it has a name, and I haven't told it where to send things, so it's now sending it to the wrong place. So we have to configure that too. That's another chance for me to show you some of the features of this editor. So we're going to configure that here. So here, configure the bindings. You type bindings. You see that there is Spring Cloud Stream bindings. If you hover over these things, you get information about them. If you click on it, you hold Control and you click on it, it takes you to the source code corresponding to that property. So we can see here that this bindings property is a map with a string as a key, and then some binding properties that you can configure in the values. Yeah? So we have to type something there, a string. We're not going to actually get content assist for that. We have to know what that is. But I'll show you where that name comes from, so you don't sort of guess why I'm typing something weird. So the name that we're going to type there is actually this here. This is the name of the channel in my source class. In the communication pattern has something called an output. And I have to define where that output is going to be going, right? So that's what we're going to do here. So I'm going to say output. No content assist for that. But notice that once I'm inside here, again, we get content assist because that thing actually has a structure again, and STS knows about that. So we can say destination, and then I have to put the same name I used in all the other apps to define where messages are going and coming from, and that's called chat. And now when I save this, we should start seeing something, if I didn't make any mistakes. There. So see the messages appear now in the UI. Okay? So that's more or less the app I wanted to make. And the next thing I want to show you is how you define your own properties so that you get nice content assist as well. Because what you saw here is that we get a nice editor. It gives you nice content assist. It even checks a few things, like if I say ABC, that's no good because that's not a number. See, so all of these things, they are there because in Spring Boot libraries there are some magic files, JSON files with metadata in them. And STS parses these metadata, and then it knows what kind of properties exist, what kind of types they have, and so forth. If you define your own properties the right way, you get exactly the same nice content assist. So I'm going to show you how to do that. The thing we're going to do is, I did some bad things here, like I hard-coded these values. That's not nice. So let's make those configurable and do that in such a way that we get nice content assist. Okay, how do we do that? Let's create a properties class. So I make a class and we'll call it ping properties. Seems like whenever I do demos, my fingers get all jittery with nerves, so I can't type anymore. Sorry about that. So here we go. Ping properties. We'll add two properties. One is a user name. This name will be used in the ping messages, so you can say foo instead of ping or whatever you want to say there. And we'll also put in a long, which is the time between the ping messages. Another good thing to do, or two good things to do, is first, put a default value for your property, because then it will also work if you didn't configure it. Then it already has a nice default, so we put something there. Nobody. And let's use the value we had there already as the default. Another good thing to do is put some Javadoc on it. If you put Javadoc on it, it will show up in the editor when you hover over things. So that's a good thing to do as well. So let's say this is the name used in messages. And then here we'll put time between messages. Okay. Let's generate some getters and setters. We just ask Eclipse to do that, because that's kind of annoying to write. Okay, we got getters and setters. And in order to make this class a properties class, you have to put an annotation on it. So that annotation is at configuration properties. So this is how Spring Boot knows that this is a properties class. And then inside here, there is a parameter, which is a prefix. So that's what's going in front of all your properties. So all the properties for my app will be chatter.something, and this is all for around ping. So this is going to be all chatter.ping. So chatter.ping.user and chatter.ping.time. Okay, I save this. Now note, when I added this annotation and saved it, a warning appears here. I'm not sure, I scaled all the fonts, but for some reason those fonts don't want to scale. I don't know why that is, but anyway. So if you can't read it, what it says here is, when using add configuration properties, it's recommended to add Spring Boot configuration processor to your class path. So remember the metadata I told you about earlier? You need that metadata for the editor to work properly, to give you the nice content assist. The properties themselves, they work already, right? But the metadata has to be there for the editor. So if I want to do, I can write all those metadata myself, but that's really a pain in the somewhere, right? So we're not going to do that, because Spring Boot can do it all for us. We just have to put this thing on our class path. And with that warning, there is a quick fix. So we just have to select the quick fix here. It will change my POM and add that thing. And that's it. Okay, that's all I have to do. It should work now. So let's go back. I could show you the metadata, but the more interesting thing to show you is that our content assist works. So let's go here, and if I type ping, you see it now knows about chatter ping time, and you can see here, that's the comments I put. So they appear there as well, okay? Let's put something fast, so we see something interesting and exciting, really fast messages. And put something here, let's say Toronto, because that's where we are. Okay. So you see that every time I make change, did you see there is some stuff happening in the console? That's when Spring Boot DevTools kicks in and reloads my app, right? you did see that it actually restarted because you saw the counter reset, but I don't see the messages changed. Of course, you should expect that because I defined properties, nobody's reading them, it's not going to do very much. So we actually have to use them as well. So let's go quickly change that here. How do we use these properties? Well, it's just a bean. So we can use it here by auto-wiring that. There's one more thing I sometimes forget to do, so let me just do it quickly before I forget. Again, you have to enable that through an annotation. So we'll say enable configuration properties, and then here we put the name of the class. Okay. Ping properties, call that ping, auto-wire, and then we can just use it here, ping.getTime, and here ping.getUser. Okay, let's save it now. I should see my messages change. There you go. So lots faster and a different message. Okay. All right, so that's kind of where I wanted to end with the local apps part. The next part I'm going to show you how these tools also work seamlessly on Cloud Foundry as well. Has anybody any questions at this point, maybe?
We have this properties defined in the application properties that gets auto-wire automatically, right?
Yeah.
Now, if we have a similar property, exactly the same name as system property, will it have a conflict? Will it override? How will it work? Or is it just combining with this?
It will, I mean, basically Spring Boot just reads your system properties as another property source. If you have somehow defined a property there that matches that name, then it will just read the value of that and store it into that property. That's all that will happen. Yeah.
Even from the system property?
Yes, yes.
Okay.
Yeah, so, I mean, I'm not the expert here, but Dave Sire could probably say more accurately what's happening under the hood. But Spring Boot reads properties from many property sources, like environment variables, system properties, properties files, probably some other places that I don't know about.
Okay.
But there are many ways to set these properties. That's kind of the point. Yeah. You can have them baked in, and then when you set a system property, it will override. So these property sources also have priorities, like some override others, like the system properties are very high priority.
Mm-hmm.
So they all, if you basically, you could write, when I set the server port in my file, and then later on I run my app and set a system property, the system property takes priority.
Okay.
Yeah? Was that the question, maybe? Okay, cool. Yeah. All right. So now let's move on to Cloud Foundry. So this here, what we call these things here targets. So these little nodes here are targets. The local target is kind of a special case. That means you run things on your own machine. These other nodes here you can add more nodes. Those are Cloud Foundry targets. Maybe in the future we might support other kind of targets, but right now there's only local in Cloud Foundry. So, and the Cloud Foundry target gets created by clicking on the plus button, putting in your credentials, choosing a space. I've already done that, so we have one here. Right now, this is actually kind of a new feature in STS. It used to always try to auto-connect, but people found it a little bit annoying. So right now, it's not connected. If you close STS and open it, it won't connect. If it's already connected and you close it and reopen it, it will connect. So it remembers whether you had something open or not. So let's connect. Connect. And you see that I've already deployed most of my apps there except for the new one I just made. So we're going to deploy the new application. And as I could tell, you could sort of see the interface is the same, right? So you can start and stop these things. You can click on these buttons to open the consoles and so forth. So it's all the same UI, yeah? The same UI as for local apps. Now let's deploy my app. And in order to deploy it, what I'm going to do is I'm going to create a deployment manifest. So let's call that one manifest.yaml because that's sort of the convention. You could call it something else too, but it's better if you follow that name because then the editor will automatically activate for it and you won't have to tell it to use a specific editor. And again, we have a nice content assist. So this manifest YAML has a bunch of properties you can define, and I used to find them kind of annoying to edit because I usually just going to find an old file, copy it, and then modify it because I couldn't remember any of those things. But now I can just write it from scratch because our editor tells us what to do, basically. So I'll say chatter ping bot is the name of my app. And you can also see if I type here, I can see the Java doc. Well, actually, this is not Java doc because it's not Java. This is just doc. So you can see the documentation side by side with your properties. If you didn't know what they did, just read the documentation and you'll know what they're for, what you're supposed to put in them. Let's set the memory, okay. Memory property. You can also get a little bit of content assist there. It suggests some values, although this is really a free-form thing. You could put other things in there. It checks. See, for example, if I forget that I need to put a unit of measurement there, it will say this is no good. Hover over this error, it says, okay, couldn't parse that because you need to put MMB, G, or GB at the end, please. Yeah. So we'll put 1 megabyte. Okay. I'm not going to put anything else just yet. Let's just deploy the app. How do you deploy an app? Anybody want to make a guess? Drag and drop, right? So just take your app and drop it onto your target. And when I deploy it, it will ask me which manifest I want to use. Because you could have more than one. Maybe you have one for your production target. Maybe you have another one for another way of deploying things. Maybe the file is not in your own project, but somewhere else where you keep all your manifests. I don't know. Maybe you do it slightly differently. But if it finds one in your project, it will pre-select it because that's probably the one you want. You can also do manual, which means you don't use a manifest that's somewhere on your file system. You just type something in here. It's a one-time use, basically, manifest, just for a quick deployment. Okay, but we'll just do this. I'll click OK. And that's pretty easy. Of course, that's going to take us a little bit of time because Cloud Foundry isn't the fastest thing. It's doing a lot of work there. It's creating Docker containers and I don't know what, a lot of complicated stuff, provisioning hosts and I don't know, lots of stuff. So give it some time. While it's doing all that, let us clean up some stuff here. So you can also stop applications. I haven't demonstrated that. So we don't need our local apps for now. Just close them all off. With one click of a button, I stop all these apps. It's still going there. The other thing I want to demo while we're waiting for that is some of the debugging tools that we have. Of course, you all probably know that you can easily debug local apps in Eclipse just by running them in debug mode. There is a button for that, this one with the little bug icon. And that button also works for Cloud Foundry apps. So if you restart, let's say, one of these services with this button here, it will relaunch the app in debug mode on Cloud Foundry and then create an SSH tunnel to that app and attach the Eclipse debugger to it. You don't have to do any special things. That's all done for you by STS. I'm not going to do that because the deploy takes a little bit too long. So I'm going to show you something else. Notice that we also have DevTools on that app there. If I can only see, there is a little word DevTools. This means that we have DevTools enabled on that application. Actually, DevTools doesn't just work for local apps. You can also use that on a remotely deployed app. For that, you have to attach a remote client to it. STS can do that for you. So you just select this, and you'll see there is a menu item there somewhere, which says start or restart remote DevTools client. So let's do that. Okay. So you see what you see here, let me move this aside so we have a bit more space. Spring Remote, that just got started. This is like a local proxy for the DevTools. It looks at your class path in your local project. When something changes, it will send it to Cloud Foundry, update the app there, and restart it. Okay, so the thing that I got here, this banner service, is part of my chat application. If I do here, oh, actually, I always make that mistake. See, that's my local guy. So my remote guy, you can open it, so like you see, the UI is all the same, right? Just double click, opens my app. If I type something here, say banner, see it says Spring 1. We're going to try and fix that because that was my demo for Spring 1. Now we're in Toronto, so we're going to change that word to Toronto there. Okay, so we're going to change the banner service to say Toronto. The word is here. You just need to change that word. And save. And if all goes well, and all didn't go well, sorry, that sometimes happens. It's live demo after all. I'll restart this guy. Of course, that's going to take another few minutes out of my demo, but that's okay. I'll come back to it later because the other guy in the meantime is finished. So let's go back to the other guy. The other guy here, the pingbot, was started, but I think it may not be very happy. So let's look what's going on in its console. See these errors here? Yeah. Why are there errors? Because I forgot something. These apps are all using RabbitMQ to chat to each other. I didn't bind any services, and RabbitMQ is a service, so we have to bind a RabbitMQ instance. The way you would, well, there's actually several ways you can bind services, and that's part of where we had a little bit trouble designing a good UI for that. So I'm going to show you our solution to that conundrum. So normally one way to do it, oh sorry, that's the wrong YAML file. Where's my pingbot? Here. Where's my manifest file? Here, okay. So one way to do that would be add a services entry here and define what services I want, okay. But let's do it differently because not everybody works the same way. Maybe you do it a different way. If I click on this, double click it, it will open the Cloud Admin Console, which is a web UI that the Cloud Foundry guys built for working with your apps. Photo.com. And sign in, okay. So it's a very nice web UI that the Cloud Foundry guys built. You can see here my space is here. My pingbot must be here somewhere. There it is. We can see services tab, and then we can bind a service there. So let's bind the service. I need to select one. There's just one available. That's quite easy. So that's the one I need. And bind it. And now I have to, so that doesn't immediately start working because when you bind the service, actually this is something that's set and bound when the app starts up. It's going through environment variables that the app reads indirectly. So you have to restart your app, or at least restage it actually. So you have to restart your app. So let's restart that banner service. Was it, sorry, no, sorry, pingbot. Let's not confuse myself. So let's restart the pingbot. Okay, and see now, normally when you would click restart, it would just do it. But because I made a change outside of the control of the IDE, I went through the web UI, I did something that the IDE didn't know about. There is a discrepancy between what your manifest says that you wrote and what is the current state in Cloud Foundry. So rather than just kind of blindly taking your manifest and overwriting what's there, it's going to say, hey, wait a second, there is something different here. What do you want to do? So it's now up to you to decide, Maybe you just did some experiment and want to forget all about it. Or maybe you don't want to use your manifest anymore and you just want to manage the state through the web UI from now on. So if you wanted to just manage everything through the web UI, you just say forget manifest. And from this point on, we just consider the state in the cloud as the thing you're interested in. Or you can merge these things manually. So this is a diff view editor from Eclipse. Has a few buttons on there to copy changes from the left to the right. So we can use that, synchronize, and now it will probably deploy correctly. So that's all I want to show you about this. So now we can go back to our banner service, which has restarted. It now says Toronto, and I'm going to have to change it back to show you that it actually works, right? Because the point of this was to show you that it can not take as long if everything's working right. So let's go back to the banner service class here. So let's say second, oh wow. Okay. And if I reload it now, it's a second try, okay? So the DevTools did work. I think what probably happens is if I play around with my demos a bit and then I reset the state in the Git repository, they kind of get out of sync and then it breaks. So that's probably what I think happened. There was one more thing. Actually, do I have time? 5 minutes? Okay. 5 more minutes? I can do it, yeah. So there's one more thing I want to show you. What if I wanted to debug my application? So like I say, you can just debug it in the cloud. But what if that's one thing to do, but actually it's not the best, not always the easiest or the best thing because the debugger has a bit of latency communicating. It's kind of slow. And so we can also run our application locally, connect it to these apps that are running in the cloud and debug it locally. So if you look at this banner service here, right, I will stop it now. And this banner service, actually, this one doesn't use RabbitMQ. This is just a REST service. It registers with Eureka, and Eureka, the other service that uses it, resolves that and talks to it. So it doesn't kind of matter where it runs. It just matters that it gets properly registered with Eureka. So if I run it locally and I can register it properly with Eureka, I can just debug it locally. And that's what we're going to do. So we're going to just run this guy locally. Click on this app in the local column here. And there is a menu here, which is restart or redebug. I'm going to use redebug because I want to debug it. Redebug and expose via ngrok. So who knows what ngrok is? You ever heard of that? No? Well, it's basically a tunneling service. Because the problem you have with your local apps when you're running it, you don't have a public URL. If you don't have a public URL, you have nothing to register with Eureka. Yeah? You can't say, access me here, because you're sort of not accessible to the internet. So ngrok is the tunneling service that solves that. So we just kind of do that. We have to tell which Eureka we want to register with. That's this one. And restart it. Okay. And I'm going to put a breakpoint in my banner service so we can see that it works. So yeah, here is my banner service. So I'm going to put a breakpoint in here so that when somebody asks for a banner, we should be hitting that breakpoint, right? It might take a little bit of time before the Eureka server and all the information propagates, but it shouldn't take too long. So I'm sort of stretching time here. But let's switch, and I think right now if I go to my UI, it's probably already registered. So Let's give it a try here. If I type here banner, what happens? The banner service is not yet there. Okay, in the meantime, let's just shut up this ping bot because it's really kind of annoying. So let's stop it. Let's try again. Oh, I hit my breakpoint. So you see, my locally running app was registered with Eureka, and then I went onto Cloud Foundry, did something with my remote application, which calls on that service, and it hit the breakpoint in my local app. So I can now just run it locally and debug it locally, just like I would any local app. Okay, let's say yes here, and it opens my breakpoint, and there we are. Okay, and how much time do I have left? That's perfect because I'm done. So I'm just going to give you one last slide to remind you what I all showed you, and then we're done. So that's perfect. So what did you all see? I showed you some wizards for creating new boot project, some wizard for managing the dependencies so you can go back and change it later, a few code templates, some nice editor support for a few files, application properties file, manifest YAML file, application YAML file. The boot dashboard as a nice place to kind of work with multiple apps, start and stop them all at once, debug them from there, do things that you might want to do with your apps, such as attach remote DevTools client, attach debugger, run them remote and local, expose a service through ngrok. So all kinds of little debugging gimmicks and things that help you kind of shorten the development cycle when you deploy things on Cloud Foundry. And that's kind of the end of my demo. So is that perfect timing? Yeah. Okay, so maybe, I don't know if we have time for questions, but if we have.
Not really.
Okay. No
Sorry.
questions. If you have questions, come and grab me later. Okay?
That ngrok thing is awesome. I've been rolling my own Eureka locally.